Welcome back, my friends. We're at JIMTOF. We're stepping into the future. I got Peter with me. Now, I am a big fan of lasers. I am a big fan of Star Wars. I'm still waiting for one of you amazing people out there to make me a lightsaber, but we're getting darn closer because we have a laser machine right here. And if I'm talking with Peter and I'm learning about Sodick, they like to create machines that maybe we don't know exactly where it's gonna fit yet, but you guys out there with your creativity are gonna let us know where it fits, and that's why they're building. You ever seen that movie? If you build it, they will come. That's what this laser machine is all about, Peter. We can actually do so much on this machine, but we're still figuring out its best uses. We're stepping into the future.
Yeah, listen, I've only seen it yesterday, and I'm thinking, hey, where's this gonna fit? But you know, that's been a process over the years with Sodick, but this is going to be the future. This is going to be where you're going to look at it and go, hey, that's a problem, I can't do that. That's the machine for me.
You know, Peter, I think you've been doing this about 40 years. I don't want to date you. You look like you're about 30 years old, but you say you've been doing this for about 40 years, and you just told me I learned about this yesterday.
Yeah.
For someone of your expertise to be learning about this as well, I can only imagine what the folks on camera want to know about this machine.
Well, this machine, it can drill, it can improve the surface finish, it can drill at certain depths. It's really aimed at the medical industry, we think, but hey, let's see. We're going to release the information and we're going to see who comes towards us and who wants a sample cut. It could be defense, it could be aerospace, it could be medical. My opinion, it's medical, but let's see.
I like when you say it's my opinion, but let's see, right? And that's gonna come. I wanna ask you a few questions about the general idea of making holes versus etching, the power of a laser. When I think about laser, it always needs an endpoint, right? If I point a laser at the ground, it's gonna stop where it hits the ground. It's not gonna stop halfway between my leg. How do you, inside this machine, change the variation of depth to be able to do 3D etching inside of there, or maybe even punch holes? And on top of that, aren't we at 12.5 micron in diameter when it comes to precision? You're micron world here at Sodick.
We are, and 12.5 microns a mile for us, let's be honest, but it's 12.5 micron in the width of the laser, and the depth is controlled by the power that we're putting into the laser and how much oscillation that we're using, so the laser actually oscillates on the material to create the surface finish or the hole that you want to require or you want to cut.
You know, my curiosity continues, and we want to keep these videos around 5 or 6 minutes. My brain won't stop, Peter. It never stops, and I always want to learn more. So we're talking about, you said 12.5 micron is a mile for you guys, right?
Yes.
In the world of etching, I would say that oftentimes precision it's needed, but it's not micron needed. And what you guys are doing, I'm bringing this full circle to the medical world you mentioned that it might fit into. You're talking truly microns in the etching and the whole world based on the oscillation of the laser itself, right?
Yes.
And you're getting into materials that hadn't really been touched by Sodick previously.
Correct. Well, we generally work with conductive materials, but actually this machine, it doesn't have to be conductive. This machine, it can cut ceramic, so we can cut very thin ceramic parts, which we feel would be fitting into the medical market too. And then when we talk about medical, we're thinking, well, you know what? The people have eye surgery, they have body surgery, and they all need small parts or small needles or whatever it might well be. So this is the market that we want to aim for.
You know what I've already realized by this conversation, and just so you know, I'm a big fan of prove it to me, show me what you've got going on, and we're gonna walk over there in just a minute to show you guys some parts, so stick around. But I've already immediately started realizing that some of the most successful companies on the planet are those that adapt to technology before we realize how important it is to get there. And a machine like this is gonna help some creative thinkers out there change the way they do their machine shop, guaranteed for more efficiency, for more profitability. That's how this type of machine works.
Yes, that's why we take people from university. Every year we take people from university, we bring them into the company, and we've got young ideas, they're young people, they're ambitious. Hey, and this is the product.
Yeah, I know you're a little bit younger than me, but do you remember the TV show Jetsons?
I do, yes.
Yeah, I think this is stepping into the future even
is.
further than the Jetsons themselves. And if you Google this as we walk on over to these parts, I believe the Jetsons was actually a futuristic show which takes place right around now, so it's a modern thing. But let's invite the camera into this general area. Here's some ceramics, which you're
Correct.
not normally doing.
Correct.
Here's a nice little design of some buildings, and here's some etching over here. Let's describe what's going on when we talk about the machine's laser capabilities, Peter.
Well, in terms of the ceramic, generally we are conductive, but of course ceramic isn't conductive. So we're cutting holes in there, and we're also etching on the top. And the next subject is actually showing, it's like a hologram. So we're going to control the depth of the laser, so it is creating a hologram in the material. And then we just move on to the materials. So we got stainless steel, we got tungsten, we got SKD11, which is a general tool steel. And there'll be different samples. Some will have holes all the way through, but some will just have like laser marking. It's just to show what this machine's capable of. Somebody out there's got to look at it and go, hey, I can't do that. How am I going to do it?
But I can now.
But I can now.
Yeah, there's really creative people out there. I guess at the end of the day, what we're describing with this laser machine, as I look at these parts and materials and these holes and the accuracy and 12.5 micron and what's required in the medical world, some aerospace components, the fact that there are parts out there right now that'll take 30, 40, 50, 60 different areas, and then as we have people walk right through, which I don't mind at all because we're at a show and that is perfect timing, what I realize is that we're going to be able to combine operations with precision, and someone really creative out there is going to change the way their shop is done. That's what I'm learning from this conversation.
That's what we want, and that's why we're here.
Perfect. Again, step into the future, step into JIMTOF, step into Sodick. Absolutely the way to change your machine shop.